Alright, this is Ken Rosever. We're continuing our discussion of expectation and variance of random variable. We went over this problem last time, and we talked about how the expectation is a weighted mean, or is kind of like one. We talked about the various ways you can get the variance, and we did indeed get 60.5 and 114.75. So we're going to do another one. To make this easier, when I get to the part that's on variance, we will take it and make a copy and paste it into the other page. But for now, we can do the calculations right here for this part, because the weighted mean is easy. You just do the value times the weights. So here we go. 3 times 0.3 plus 4 times 0.05 plus 5 times 0.05 plus 6 times 0.15 plus 7 times 0.15 plus 8 times 0.30. Enter. 5.7. And that looks reasonable because the 30 here and the 30 there kind of balance, and the 5s here and the 6s here, these pull it away from 5.5 and maybe pull it a little higher. So I'll buy that 5.7 as a reasonable answer. So now keep it in mind, because we're going to take a picture. So here we go. Taking the picture, and 5.7 was our mean. We bring that in. Ooh, I hate when it does that. Forgive me, I'm going to try it one more time. I forget that I have to click somewhere first so that it'll bring it in around that spot. There we go, that's a lot better. Alright, and I don't know which way you prefer to do it. But we proved in the last one that both ways work. So it's really up to you. I think in this case, though, these numbers are very easy to square. So it's easier than doing the subtraction and then the squaring to just square those. So I'm going to do it with this formula right here. So in order to do that, I need an x squared column. Here's my x's. So x squared will be 9, 16, 25, 36, 49, and 64. And now I'm going to multiply the x squareds times the probabilities and then take their sum. So it's going to be 9 times 0.3. Actually, let me use parentheses. And what I'm doing here is I'm doing the p of x's. 0.05, 0.05, 0.15, 0.15, and 0.30. And I'm going to do those all really quickly on my calculator. So 9 times 0.3 plus 16 times 0.05 plus 25 times 0.05 plus 36 times 0.15 plus 49 times 0.15 plus 64 times 0.3. Enter. And my answer is 36.7. And what else do I have to do? I have to subtract the mean squared. I think the mean was 5.7. Let's just go back and make sure. 5.7. So hopefully, so we're doing this right. So I'm going to minus from that 5.7 squared. 5.7 squared is 32.49. So our answer is 4.21 is the variance. So Hopefully that's right. Hopefully we made no errors. It's so easy to make errors on these, but I'm going to trust our result and hope for the best. Here we go. Hitting next. Please. Yeah, we did it. Good job. Alright, you want to try one more? I don't know that we need to. If you get it, you can stop the video here. But if not, here's one more. We're going to go 0.15. Oh wait, 0.15 times 0. Right? When the value is 0, it doesn't matter what the weight is. So, skip that one and go to the next one. 10. I mean, you can still put it in, but it won't make a difference. Plus 20 times 0.25 plus 30 times 0.3. 17 is our mean. On this one, I'm going to use the second formula because 17, I don't know, it'll make it easy. Okay, so what I'm going to do is I'm going to take those differences and square them. Do I want to do that? Maybe not. No, I won't do that. I will use the first formula, the shortcut formula. Here we go. 0. This is kind of cheesy, but just for notation, I'm going to square it, and I'm going to multiply it by 0.15 plus 10 squared times 0.30 plus 20 squared times 0.25 plus 30 squared times 0.30 minus 17 squared. That's the sum of the x squareds times their probability. You remember that's also called the expectation of x squared. So it's the expectation of x squared minus the expectation squared, or the mean squared. And it equals, and it's 111. So we had 17 there, and hopefully 111 here is correct. Yeah! Practice again. If you answer correctly without help, it's going to add it to my pie, but I'm not going to do that tonight. I think that's enough. Alright. Later. Bye.